Good morning, everyone. So this webinar is very special because it's the first one in 2023. The title of this webinar is Techniques to Improve Nutrient Use Efficiency, Social, Environmental, and Cost-Saving Benefits from Mitigating Environmental Nutrient Losses. And we are so lucky to have a guest speaker this morning, Louis Poiron from GrowSafe. And Louis will be able to share more about who he is, what he does, and as well as today's webinar. So without further ado, I will welcome Louis to share. Thank you, Louis.
All right. Good morning, everyone. Yes, yeah, you'll see that I talk funny. I came from Canada 17 years ago today, actually, and have always been involved in agriculture and plant and soil health. And yeah, 17 years in Australia. It's given me enough time to wrap my brain around how plants and soils function in different environments. Been with GrowSafe now for 4 years this month, and there's a lot to be learned from having seen plant and soil life, both northern, southern hemisphere, different climates. So anyway, thanks for participating, everyone. Hope you ask lots of questions. We'll try and cover everything. We've just got a 7-slide presentation, and thanks, Lara, by the way. We also have with us Tom Frost, who's part of GrowSafe AMF. So yeah, we'll go through quickly these 7 slides so that the participants have an idea of what we're sort of going to cover, and then quickly, and then we'll go back to the first slide and work our way through more in depth through each one to hopefully raise some questions and answer some questions. So yeah, look, yep, GrowSafe is sort of a sub-brand of Australian Mineral Fertilizers. Where GrowSafe AMF is, actually, we see ourselves as much as a food company as a fertilizer company, but what we're really about is minerals, trace elements, and microbes. So we look at the 3 sort of dimensions of food production, soil and plant health. So the physical, chemical, and biological side of this whole ecosystem. So that's GrowSafe. So look, obviously with Strata Green, we're looking at more commercial sized products on either to be used on golf courses or landscaping, footy ovals, cricket ovals, in that side of the industry, and how our products can help balance favorable outcomes in what we're trying to do. So first of all, I can compare, say, a footy oval or a golf course to a monocrop, say in broadacre, right? Okay, so a monocrop is just a single species of plant, or maybe a couple of species of grasses, let's say, that grow on an oval or a golf course. So whenever you have a monocrop, right, there's no monocrops in nature. So whenever you have a monocrop, it can lead to a monoproblem, because nature always tries to balance itself. So, and in nature, there's diversity. So when we try to narrow that diversity, we need to be aware that a balance wants to be reestablished. And if we're trying to culture an imbalanced footy oval with only a couple of species of grasses, there's going to be an imbalance in the biological side, or the animal side. So, for instance, you might get a black beetle problem emerge or some sort of fungal problem because the balance of biodiversity isn't there for it to be all self-controlled, right? So nutrient use efficiency is affected by all these things. So what we're talking about there, nutrient use efficiency, is the scale of a plant's capacity to uptake fertilizer nutrients, right? So you've got, again, the physical, chemical, and biological side of soil and plant health. And, biology is being spoken of a lot more in broadacre, in pastures, and even in golf courses and footy cricket ovals or landscaping, around city properties, parks, right? So factors such as soil moisture, temperature management practices, soil biology, and fertilizer characteristics can influence nutrient use efficiency. And so I'm also a bit of a microbiologist. So, this biology is also a science, and it's a bit more challenging than, the physical or chemical side of say, soil health, because biology is a living thing. So it's a bit of a moving target, and it might evolve in ways that are a bit harder to predict than a certain chemical reaction, right? So, but it's nevertheless very, very important. So once that's addressed, it helps to balance the physical and chemical side. If we only address the physical and chemical side of a system or an ecology, we're missing out on a large segment, the biological side, and how that influences the health of a monocrop, right? So research suggests the uptake efficiency of traditional fertilizers can be as low as 50% for nitrogen, right? So this is all based on a lack of addressing the biological side, in my opinion, and the type of fertilizer you use, in what form. So nitrogen is not just nitrogen. There's liquid nitrogens. We do granular. We use granulars. 10% of the phosphorus, up to 90% loss or top. So why is that? There's some basic things we can look at. 40% potassium, up to 60% loss. So because these inputs are costly, if we use the correct input at the right time, correctly placed, we can make better use of that dollar investment. All right, so that's a quick look at nutrient use efficiency. Here's the next one: is remaining nutrients can become environmental losses through volatilization, locked up, or leaching. So volatilization, for instance, some fertilizers surface applied. We know urea is subject to volatilization. You can water it in, but then, depending on the rate applied, can have an acidifying effect, and we know it has an acidifying effect on the soil. Hence, then you can, if you don't question these things and you just keep doing it, and then you think, oh well, I need to put some lime to lift the pH because the pH of the soil is a bit low, and we know that plants grow better in a soil that's not so acidic. So then we put lime, and then the next year we put urea on again, and we acidify it. So then we go and we chase some lime to lift the pH, and then you sort of start chasing your tail. So if we back up and look at the big picture and say, okay, what can we do different? So this is why this AMF and Grow Safe was created in the first place, having questioning things and having another look and choosing better inputs and addressing the three-legged stool, the physical, chemical, and biological side of a healthy system. right? So volatilization, locked up. So locked up, you know, it's primarily a calcium phosphorus bond that's giving us issues. So, you know, some of the first fertilizers that come out were you know, superphosphate. So that's a plant available phosphorus that's, you know, been manufactured. So you know, you can see an effect, but then you start chucking some lime on there, calcium, or naturally occurring calcium in the soil. Right away, phosphorus is very reactive. So then that's what happens when it becomes locked up. All right. So, and if we're not creating a healthy rhizosphere with healthy roots, including, you know, mycorrhiza, you'll hear mycorrhiza a lot, to access that phosphorus. Okay. And then leaching, obviously, you know, can apply some fertilizer, but if the plants aren't requiring that amount, and you have low carbon in your soil to provide a buffer to hold those nutrients, then it can be subject to leaching. And if you're, you know, watering too much, or if there's, you know, too much rain and you haven't got a buffer in organic matter to hold these nutrients and so forth, or chelated fertilizers, then there again you can lose invested dollars to leaching. All right, so this is a bit, you know, the basis of our success is, you know, nutrient use efficiency, addressing all the limiting factors. So it's not just NPKs, nitrogen, phosphorus, potassium, sodium, you know, that you can add as a fertilizer and see a visual result that might make you feel good, especially in broadacre and in horticulture and, you know, animal production. You can get lush green growth, which looks good, but you'll eventually compromise the rest of the system if you dilute the other minerals with an excess of NPKs, right? So these other trace elements have a lot to do with animal health at the end of the day, and plant health. Many of them play a huge role in plant health, like silica and, you know, molybdenum for, you know, for rhizobia to be able to you know, infect roots to fix nitrogen. So and there's a microbe attached to every one of these trace elements to, you know, phosphobacter to help solubilize and make these minerals plant available. So, and then, you know, the microbe side, there, you know, we're still learning. There's a tremendous amount to be learned through observation and results, and addressing and inoculating, you know, with beneficial microbes that have been either compromised or taken out or neglected, right? So the two work together. Okay, so just looking at so colony forming units. So there's a, you know, a lot of results and research and trials have been done over many years, and this is mainstream now. So these microbes, as a microbiologist, I can see these under the microscope. It's absolutely fascinating, and the microbes we use are, you know, again, diverse. So what we're doing is reestablishing the diversity of microbes. If, you know, if we've got monocrops growing, such as grasses, or, you know, if you're broadacre cropping, you'll just do one sort of species of plant in the paddock once a year and spray everything else out. So that takes out the diversity of microbes that supports this growing system, right? So and these microbes play a role in plant health defense but also remineralizing and nutrients and taking up those nutrients into the plant, right? So we cannot neglect microbes. Everything is microbially driven, whether you inoculate your plants or not. You know, a conventional system more than likely addresses only the physical and chemical side of production. And then the microbes, well, they're there. But some of the things we do compromise the microbial side, right? So it's very important to address all three. Obviously, I can hammer that home as much as possible, right? So backed by evidence, 20 years research and development. So this has been, demonstrated time and again through agricultural associations, farmer-led research groups. We've got one going on at the moment near the plant at Tenterton, near Cranbrook, Tambalup. So, just a trial as a demonstration on determining the outcomes of inoculating, a wheat crop in this instance, right? And evidence that we see in results from programs we've done with other clients. I've worked with shires on ovals, for instance, and so the evidence we get back is, oh gosh, you've drought-proofed our system, because having addressed the microbes and the trace elements, we've got better root development, which holds more moisture because this is carbon-based, right? So carbon can hold 14 or 16 times its weight in water. So if you have better root development deeper as part of your management, you have a bigger biomass, and you can see it in the evidence when people tell you, oh well, I haven't had to water as much. The crop hung on longer, and so on and so forth. Let me read some notes here. The other thing I got to mention while I think of it is, so in the system that you're using, you have to understand you may be getting benefits out of certain processes. For instance, pesticides you may use, you may see an immediate benefit, but you have to understand that there may be some detrimental things that you need to repair. Okay, so let's just take an insecticide, for instance, a beetle problem. So that upsets. You may solve your problem temporarily, like taking a Tylenol, but long term you can upset that balance, that biological balance. So just to explain that a little bit further, between the bacteria and the earthworm, there's about 7 levels of microorganisms in there, and they're all important. They're all a link in the chain in remineralizing nutrients. So if we take out black beetles, which are quite a large creature near the earthworm side, these pesticides aren't selective to the black beetle. You'll be taking or affecting the links in the chain all the way back down to the bacteria, right? So then what happens? You kind of shock the system when you do that. You might get a desirable effect to stop your black beetles doing causing you grief, but you'll eventually get another problem manifest itself in either slower remineralization or the development of some plant disease, Okay, so and so we get this feedback and we see this evidence, when we address the limiting factors, which is quite often the biological side, and the softer on soil type fertilizers, and that's the chemical side. For instance, one of the main differences is using sulfate of potash as opposed to muriate of potash, right? So muriate of potash is cheaper to buy, but it's potassium chloride. So depending on your proximity to the coast and chlorides in the rain, if you add more chlorides, what effect does that have on the functioning of your soil in terms of the balance of nutrients, right? So that's the chemical balance. So that leads me to soil testing. So if you know where your starting point is by soil testing, well then you can balance that chemical side, which is calcium, magnesium, potassium, sodium, right? And we know what those balances are. And then so if that's addressed as a limiting factor, then you address the biological side. So you can balance physical, chemical, and biological things individually, and once those are balanced, well, then they balance each other. That makes sense. So where are we? It's number 6. Okay, so phosphorus nutrient use efficiency. So there's a FACE group. So that's one of the groups that has done trials, including our products over the years. So there you can see P units applied 16, phosphorus nutrient use efficiency 18.1%. When you're using GrowSafe, you're going to apply less units, but if you have more use of those units applied, well, that means you can put less on, but make greater use of it through, phosphorus, for instance. The big influence there for phosphorus use efficiency is, again, mycorrhiza. What mycorrhiza means fungus root. It's naturally occurring. It's nothing that we magically dreamt up of in a lab. But if we know and can see through a microscope that it's limiting or it's been compromised, we re-inoculate with it. And yeah, you do get better use efficiency out of applied phosphorus. And then, yeah, again, the phosphorus source is important. We use, muriate of potash, monoammonium phosphate instead of diammonium phosphate. And there's some subtle differences in their beneficial or negative effects on the soil. And then guano-based products, natural-based phosphorus sources. Right, and all these products are available at Strata Green. So yeah, hopefully you've got some questions, yeah, we can start to address some. So, and along with this, we were talking with Tom yesterday, water use efficiency. So just one thing about water: if you use irrigation water, what's your water source? Is it scheme water? Is it chlorinated? What happens when you use a lot of chlorinated water? How does that affect your soil and plants long term? So that's something to think about. That can also be addressed. But as long as you know that, oh, maybe I'm working against myself if I'm just using this water source, and what can I do about the negative effects of my water source?
First of all, thank you, Louis, for your sharing. Very educational, and I think everyone find it beneficial. We have a couple of questions that is actually submitted to us prior to the webinar for registrant who knew that they wouldn't be able to make it live, and looking forward to get the recording. There are some questions such as the first one would be, does improving nutrient use efficiency have an impact on water use efficiency? Very good question.
Does nutrient use efficiency have an impact on water use efficiency? Well, okay, so in terms of carbon deposition, right? So carbon is very important. Root development, the rhizosphere is carbon-based, you know, so carbon drives everything along with biology. So to get nutrient use efficiency, right, you need the right source of nutrients, softer on soils source of nutrients, and the diverse nutrients, along with the biology to get nutrient use efficiency, which grows a greater carbon deposition, right? So when plants photosynthesize, they put sugar in the soil, carbon, and they give the microbes nutrients or this carbon energy, and then the microbes give the plant the nutrients. So you want to maximize the efficiency of that system. And if you're retaining your nutrients in this carbon buffer, of course it stands to reason that you'll need less water. Okay, so water use efficiency, you know, you'll have less water percolating through your root zone if this carbon captures and hangs onto it. All right, so, and that's very important. If you only get, you know, say 10 mil of rain, is that going to run off the top because your soil is non-wetting? You know, a non-wetting soil is a problem that we created by using too much of the wrong kinds of fertilizer and neglecting the biological side. Okay, so if you address nutrient use efficiency, you'll address carbon and you'll address water use efficiency.
That's amazing. Thank you for the answer, Louis. I would like to invite all the participants as well. If you want to submit question, you can click on the Q&A section on the chat, and then we can answer that live. While waiting for that, the second question that has been submitted to us is also this one. Are there inputs or management activities that are detrimental to soil microbes? Once again, are there inputs or management activities that are detrimental to soil microbes?
Yep, interesting. I'm working with a shire that uses, treated effluent to irrigate certain ovals, because there's nutrients in this treated effluent, right? So how does that affect things? So you'll only know by soil testing and getting a scientific analysis of what's going on in your soil, having treated it with this effluent. I suppose you could test the effluent, but if it's diluted a lot with water, and you spray it on your oval in this case, or it could even be, I suppose, a golf course or a park. But the big thing there again is the biological side of this treated effluent. So it'll change the microbial function, which, and we said earlier, microbes govern everything, from the soil up. So the soil is the stomach of the plant. So if you've got a ruined microbiome in the soil, you're not going to feel good. So the input of a treated effluent. And another input or management thing is mowing. And I don't know if any of you listening are involved in groundskeeping, to that extent. But mowing, the timing of mowing and the frequency and how low you cut. Are you just, for instance, if you're mowing an oval, are you going by the clock? Oh, it's Thursday afternoon. This is when we usually mow the oval or the golf course. Well, plants don't grow so much by a clock, right? So the more you do need to maintain grounds for aesthetic reasons, but maybe we need to pay attention a bit more to the soil health reasons. Okay, so maybe in the off season you don't need to mow by the clock, say on an oval in the off season, because if you let grass grow more, you'll get more root growth, right? So on average, you'll get as much sort of root matter as there is above ground matter or biomass, right? So if you just keep that grass really short and you just mow out of habit or by the clock, and you don't let those roots develop, well, you're not going to get as much carbon deposition to host beneficial biological life that is responsible for mineralizing your nutrients, holding moisture, and all the rest of it. So if we understand how that works, we can maybe question, maybe we'll wait a few more days before we mow so that the roots can grow bigger, deeper, build the carbon soil moisture holding bank, the buffer of holding more nutrients, right? So that's a management thing, the timing and frequency of mowing. So those are just two things I can think of.
Yeah.
That hopefully answers
Thank
the question.
you. Yes, thank you. And another one that also came to us is, what are some of the means to increase biological activity in the soil? Once again, what are some of the means to increase biological activity in the soil?
Yep. So understanding that if you overwater or use chlorinated water, it's going to affect the biology. Okay. So initially, obviously, you can re-inoculate. Take a sample. I can look at it under the microscope, for instance, to see what's there and what's not there. What I'm looking for is diversity in microbial life, so that all possible factors in nutrient uptake are addressed. That means diverse biology. So fungi and bacteria, okay? And there's thousands of species. So I'm looking for diversity there. So we know we're limiting ourselves in diversity if we're monocropping, grasses on an oval or a golf course or a park. So we need to, have plants that host as many, symbiotic microbes as possible, and try to minimize the impact of some of the things we do that might be negative to that.
While waiting for other questions that might be sent through, maybe Louis or Tom have any additional thing to say before we wrap up?
Just on furthering Louis' questions there, or regarding the, techniques to mitigate reduction in biological activity. So obviously there's certain management practices that can influence that. Simple things like ground cover, so bare soil, UV exposure is pretty detrimental to that biological activity. So you're leaving soil exposed without anything growing on that is generally regarded as pretty detrimental to it. Obviously, excessive water. So if it's areas that there's not much aeration going through that is something to keep in mind. Obviously, certain chemical use, fungicides in particular, can be quite detrimental. So if those are applied, we do recommend coming back with inoculation to address that. So if you're killing out one bad fungi, you're also wiping out maybe some beneficial ones too. So it's about that re-inoculation and things like companion planting. So there's certain plant types that do have are renowned for their especially native Australian plants, for example, with their associations with certain fungi like mycorrhizal, and it's important for their reproduction processes. So there's a number of reasons why to keep obviously your biological activity healthy and well in that soil. So fundamentally, I think those are the key ones, Louis, but unless you wanted to add any to it. Louis, would you say there's anything specific to, be it shires, be it golf courses, be it re-veg, when it comes to nutrient use efficiency? So obviously stratas here in WA, we've got the Swan River region, and that's quite susceptible to pollutants causing algal blooms. So you've got your what was addressed a number of years ago was the phosphorus impact on that. What we've actually seen though is now we have nitrate blooms rather than phosphate blooms in the Swan. So is there any other means or strategies that could be addressed when it comes to those? Is it obviously we're working with granular products. There's obviously liquid products in the market. There's obviously a whole range of different NPK products out there, which have varying levels of concentrations. But as you explained, it's not always about the highest concentrate doesn't mean the best product from a financial perspective or environmental perspective.
Yep, exactly. So depending on soil type, on the subsoil beneath your surface plants that you're growing. So if it's sandy or clay, whatever. So depending on soil type, and a soil test so that you know where the levels are to begin with. Then you can determine the rate of application, but you may also need to look at split applications because the soil can only hold so much. The cation exchange capacity, cations are, positively charged. The soil is negatively charged. The soil particles, the clay particles in the soil are negatively charged. Well, if you have a sand soil, you haven't got many clay particles. So then you have what's called the cation exchange capacity. So if you have a soil based on soil testing results with a low cation exchange capacity, you're going to want it to do split applications to mitigate losses. There's catchment groups right throughout the Southwest, water catchment groups that do soil testing, and the focus is on mitigating phosphorus and nitrogen runoff into the waterways and hence into the ocean. Because number one, it's a waste of money. Number two, it harms the environment, and we can't keep going that way. So, yeah.
Thank you for that, gentlemen. Tom, thank you for jumping in with that. I think it's very important to be asked, and it's great that Louis clarified and as well answered the question. I believe there is so many of us wanting to know the answer to that question as well. Yeah, so I think that was the last question for this webinar that we have covered. Once again, for those who just joined in and maybe missed the first bit of the information, don't worry, rest assured, you will get all the gold that Louis has shared today. Once again, on behalf of Strata Green, I would like to say thank you for Louis for sharing, as well for Tom for being here on the webinar. Both of them are from Grow Safe. And if you have any question, anything at all, just shoot us an email, info@stratagreen.com.au. We will be able to assist you as well as work with Louis and Tom to get your questions answered. That's the very last bit of the webinar. Once again, I thank you everyone who participated on the webinar. Again, for Louis for sharing such a invaluable information. And we learned so much this morning, and hopefully we can do it again sometime soon in the future.